Hello everyone, welcome back to my YouTube channel Learn with Sumi. In this video, we are going to do indeterminate forms. I know that your exams are going on and I just wanted to be helpful to you guys, okay? Support me so that I can support you with more and more topics, more and better explanation, okay? And I'm planning to post, what do I say? The notes as well, okay? So I'm trying to write it neatly in separate pages so that it will be helpful for you, and I can give it to you via mail or any other platform. So if you have any doubts, please reach out to me on Instagram as well. I have posted that on YouTube, the QR code and the link as well. So do not forget to reach out to me on Instagram if you have any doubts. We can, if you want, we can on weekends we can set up a webinar or anything online platform, and I can clarify your doubts with no cost at all, okay? I won't be charging you anything for the doubts, as I have uploaded for the videos. But if you want anything separate, then we can discuss about it. So let's get started. Here we have like indeterminate forms. Indeterminate forms under module 2. So what is indeterminate form? It involves basically two functions whose limit cannot be determined and which are of the form 0 by 0, infinity by infinity, infinity plus infinity, infinity minus infinity, 0 multiplied to infinity, 0 raised to 1, 0 raised to 0, 1 raised to infinity, infinity raised to 0. So these are all indeterminate forms, correct? You are already aware of these forms in your previous classes, previous courses. So 0 by 0 is indeterminate value. Infinity by infinity is indeterminate value. Infinity plus infinity is indeterminate value. So all the examples I have mentioned here are the indeterminate values, okay? So we have something called as L hospital rule to evaluate these type of expressions, okay? We have L hospital rule. I'll just highlight this L hospital rule. If you know this already, then well and good. If you don't know, then I'm going to make sure that you understand what L hospital rule is. So it's a method to evaluate indeterminate forms such as what? 0 by 0, infinity by infinity, infinity plus infinity, and so on, okay? So we are going to use L hospital rule. So I'm going to explain you more. So to evaluate, okay, okay, I'll just pause the video, I'll write down the sentence, and then I'll just start explaining to you again. As I was saying, to evaluate the limits of indeterminate forms, okay, for the derivative in calculus, L hospital rule can be applied more than once. What do I mean by more than once? L hospital rule, okay, I'll explain what L hospital rule is, and it can be applied more than once. So you will get clarity on this when I move forward with the video, okay? So let us consider f of x and g of x be the two functions, okay? So these are the two functions. Then the indeterminate form, okay, indeterminate form of these will be in form of limit x tends to a f of x by g of x, which is equals to 0 by 0. Okay, let me consider this as equation 1. So this will be in the form of this. F of x is a function, g of x is a function. Here it will be in the form limit x tends to a. X tends to a. Here it is going to be some value, okay, 0, 1 or whatever it is. X tends to a. F of x by g of x is equals to, this value should be 0 divided by this value should be 0. Not necessarily, but it should be in some indeterminate form, like 0 by 0, infinity by infinity, or infinity plus infinity, 0 multiplied to infinity, any of the indeterminate forms, okay? So this is what this will be This is the indeterminate form. So I'll just highlight this, okay? Just bear with me to understand better, what indeterminate forms are. I will explain you with more and more examples. As per as per L hospital rule, okay, L hospital rule, differentiate both f of x and g of x, okay, separately as per L hospital rule. Differentiate both f of x and g of x separately. It is E, or what is the spelling? I'll write A only. Separately, okay, and apply the limit value to get determinate value. Okay, so as per L hospital rule, differentiate f of x and g of x separately and apply limit value until we get determinate value. So for example, you're differentiating f of x and g of x separately, you got some indeterminate value. You differentiated that again, okay, so you got again some indeterminate value. So you will keep on differentiating these two functions again and again until you get some determinate value, okay. So I will show you what that means. I'll show you what that exactly means. So L hospital rule here, limit x tends to a, okay, f of x, I'll just rewrite that form, f of x by g of x, okay, which is equals to 0 by 0, right? So I'm differentiating this f of x and g of x separately, okay. Limit x tends to a. So let me consider f dash of x divided by g dash of x, okay, for our reference, which is equals to, consider I got the differentiation also as 0 by 0. This is also indeterminate, right? If I got this, let me consider this as equation 2. I will differentiate this 2 again separately with respect to x. Of course, we have x here. So L is equals to limit x tends to a, f double dash of x divided by g double dash of x, which is equals to, let me consider, I got some determinate value k. Okay, now I can stop differentiating further. Okay, now let me take some examples to explain you better. I just want you guys to have, complete clarity on this L hospital rule. Okay, examples I'm gonna take. So let me go for like evaluate the following indeterminate forms. Okay, so the first one I'm going to do is for limit x tends to 0 sin x by x. See what happens if I directly apply 0, okay. L equals to limit x tends to 0, okay, sin x, it is going to become sin 0 divided by x is 0, which is equals to 0 by 0. Correct? Is this indeterminate form? Yes, it is indeterminate form. Now what I'm going to do is apply L hospital rule. Okay, I will apply L'Hospital rule. So my equation 1, you know, it will be L equals to limit x tends to 0. This is one function, this is one function, correct? This is one function, this is one function. I applied the limits here directly. So this is one function, this is one function. If I differentiate sine x, I will get cos x. Differentiate x, I'll get 1, correct? Now L is equals to, I will just apply the limits. I'll apply the limit. So when we apply the limits, we do not write this limit extends to 0. So it becomes cos 0 by 1, which is equals to, what is cos 0? Cos 0 is 1 divided by 1, which is equals to 1. We got some determinate value. 1 is a determinate value, correct? Now, I have one more example for you, for your better understanding. Limit x tends to 0 tan x by x, correct? Now see, if I directly apply the limit tan x by x, okay, limit x tends to 0 tan x by x. So tan 0 is what? 0 divided by 0 is 0. So let me consider this as what? Equation 1 here again, okay. So after I apply L'Hospital rule to this, apply, as this is indeterminate form, I'm applying L'Hospital rule, okay, to get determinate form. So I'll apply L'Hospital rule. So this equation becomes what? Limit x tends to 0. Sorry. So differentiation, this is f of x by g of x. Differentiate this separately. So tan x is what? Differentiation of tan x is secant square x divided by differentiation of x is 1, which is equals to secant square secant 0, okay, secant of 0. I'll just apply the limits. So once I apply the limit, it becomes secant square of 0 divided by this is 1 itself, correct? So secant 0 is 1. So 1, here I have square. So 1 square by 1, which is equals to 1. I got the determinate form. Now the next example I have, is of limit. I'll just write it down. Okay, I'll just write it down. Limit x tends to 0, a power x minus b power x divided by x. So here it becomes, if I just apply zeros here, it will be like a power x, let me write it, a power x b power a minus b power x divided by x, which is going to be a power x is 0. A power 0 is what? Anything to the power 0 is 1 minus b to the power 0, anything to the power 0 is 1 divided by, this is going to be 0. So 1 minus 1 is 0 divided by 0. This is indeterminate form, correct? This is indeterminate form. So I have considered as equation 1. Now I'm applying L'Hospital rule. Apply L'Hospital rule. So after applying L'Hospital rule, it will become limit x tends to 0. What am I supposed to do? Differentiate with this separately and this separately with respect to x. So differentiation of a power x is what? A power x log a, sorry, this is log, okay, minus b power x log b, okay, divided by differentiation of x with respect to x is 1, correct? Now I will apply the limits. So after applying the limits, it becomes a power 0 log a minus b power 0 log b, okay, divided by 1. Now it is nothing but a power, anything to the power 0 is 1. So it is simply log a minus b to the power 0 is 1, log b divided by 1. So even if I don't write 1, it is fine. So log a minus log b, if you remember the formula, that is what? Log of a by b. Okay, this is some determinate form. Log a by b is some determinate form. So thank you so much for watching. If you haven't subscribed to my channel, do subscribe, share it with your friends as much as possible, as this is exam time, critical time for you guys. So a friend in need is a friend indeed.